Well, hello there, and welcome back. Are you finally to the part in your tiny home, van, or bus build where you need power? Feeling a bit overwhelmed? No worry, have no fear. We got you covered. With this new 6-packet, 7,000 page per packet system, we will walk you through with the most complex diagrams of things you don't even need to know. That's right. For just a simple payment of $8,000 for 4,000 years, we will have you covered. We'll cover things like wires that you don't need, electrical components that make no sense. We're going to send you a whole box of stuff. Now you got to pick through what you need. Don't use the ones you don't. We'll have you wired and fired and fired and wired in no time. Well, maybe not fired because we don't want that. In addition, these packets are not just overly complex and full of nonsense. They come in one of 3 dead languages: Latin, Sanskrit, or Gibberish. It's up to you. That's right, guys. Just 6,000 payments of 47 cents per payment, and we will send this to your door with a box of useless components. All right, episode 14, Power in the Bus. Here we go.
Right across this country into the starlight, 12,000 miles, turn back, do it again. No destination, it's just a journey. You were my lover and friend.
Welcome back. This is episode 14, the electrical power system that runs the whole bus.
I'm getting my head nodding ready for this episode because I do not know a lot about electrical and power systems. I am learning and Drew is teaching me, but he is 100% taking the lead on this episode, so I'll just sit and nod my head.
Well, I'm going to try to do my best, and let us just start by saying we are not certified electricians, and we're certainly not electrical engineers, though we have learned a lot over the several builds we have done and continue to learn. Try to share my best knowledge as I know it where I'm at to help out.
For your own build, make sure that you get someone to check over your work that is certified and knows what they're doing if you are unsure.
So on the roof we have 3 350 watt solar panels making a total of 1,050 watts. The battery bank is 2 200 amp hour 12 volt batteries linked in series for a 200 amp hour 24 volt battery, or in terms of 12 volt that would be 400 amp hours of capacity. First thing we want to talk about was choosing the sizing for the system. This bus we decided to go with a 24 volt system, which means it's a 24 volt battery bank, and we have panels that correspond that are able to charge at a higher voltage. So make sure you match those things. But the reason you choose the size for the build is really based on what the size of the system is going to be. Now, if you were to try to pull the same watts through your solar into your system on a 12, 24, or 48 volt, the smaller system, the 12 volt, you're going to need bigger wires because the amperage is going to start getting too high for those wires. Whereas as soon as you jump up to 24 or 48, you can use a much smaller wire. And that saves a lot of money. Wire gets very expensive. And the same with charge controllers. Generally, a lot of them you'll see them rated for a 12 or 24 volt system, and they can automatically identify your battery bank usually when you plug them in. You can usually get twice as many panels in terms of watts on the same charge controller in a 24 volt system versus 12 volt. So if you have a charge controller that's rated to handle 800 watts of solar for 12 volts, it's generally going to be like 1600 for your 24 volts or somewhere near there. So if you had over 1,000 watts, for example, and you're building a 12 volt system, all of a sudden you realize, man, this is the biggest one I can find. And there are like some larger ones. This thing can only handle 800 watts of solar at 12 volts. Now I'm forced to make a decision of, do I put 2 charge controllers together? And that's going to be a little more annoying and complicated and take a lot more money because they get expensive. Or can I go up to a bigger voltage system? So now I go up to 24 volts. Oh, and I have plenty of headroom because I'm still only at 1,000 watts. The watts don't change. So now you can do that with no problem on that same charge controller, and you just saved yourself hundreds of dollars, because when they get that large, they get pretty expensive. There's nice sizing charts that you're going to want to look at. It'll show you the distances traveled and the gauge you would need for each amperage at each voltage. I know I'm throwing a lot at you here. Point is, without getting too crazy, we went with 24 volt system because in the long run, it's cheaper on your wire and your components like your charge controllers. If you have a very small system, you can stick with 12 volt. In conclusion, we went with the 24 volt system. So we have solar panels that are capable of charging above 24 volts to power our 24 volt battery, which is actually two 200 amp hour 12 volt batteries connected in series to make one large 24 volt 200 amp hour battery, which is the power equivalent of 400 amp hours on 12 volt system. So starting on the roof, we have our three 350 watt solar panels. They are linked in parallel, meaning all three positives will meet at one point and all three negatives will meet at one point to send just two wires into the bus. Once all the wires are in parallel, we bring in the positive and negative into the bus, and we go to our first protection in the system, and that is a circuit breaker, which simply allows us to turn on and off the feed coming in from the solar panels. With all breakers and fuses in your system, you're going to want to make sure they're sized appropriately. There's lots of charts and equations online you can reference. You don't need to know these things offhand in your head. From your circuit breaker, the next step is to send the wires to your solar charge controller. This is absolutely essential in a solar system. It's what protects your batteries. Basically, it takes the voltage coming in from the panels, regulates them to a voltage the batteries like to be charged at, whether that's 12, 24, or 48 volts. If you have the charge controller that's appropriate for that system, it will send a signal out that is what the batteries really want to be charged at and protects them from ever overcharging. Another one of the cool features on the charge controller is it has a remote display screen that will show you what you're bringing in. While you can read that on the controller, you can place this screen other places in the bus and you can mess with the settings on it.
It has a happy face on it.
Got a happy face on it. And that charge controller, if you so please, you could even connect it to a computer and download information and interact with it that way. From your solar charge controller, we're now going to send the wires along to the bus bars. This is sort of the distribution point where everything meets. So we'll keep those there for now, and let's take a step back and go back to our batteries. So we put two 12 volt batteries in series, meaning we connected positive to negative, which multiplies the voltage from 12 to 24. And then we took each positive and negative on the ends. We're going to run those up to our bus bars. But first, we're going to do another protection. On our positive sign, we're going to run this into a mega fuse. Once again, with all fuses, you need to size this appropriately. If you were to use too large of a fuse, the fuse would never trip before the wires heated past a dangerous level. So you need to make sure this is the correct thing. The idea is the fuse blows before the wires can ever get hot enough to cause a fire or anything like that. So from that fuse, we ran the positive to a master shutoff switch. This is really nice to have. I didn't put this in our bus, so if I ever want to work on anything, I just disconnect my batteries. So you don't need it, but definitely recommend it. Just makes it so much easier. You switch that, and now there's no current going beyond that point. So if you need to mess with any components, you don't need to worry about being electrocuted, shocked, all that. From that master shutoff switch on the positive, that connects to your positive bus bar. And back from your battery, your negative feed goes directly to your negative bus bar. Now that we're back at the bus bar, I want to talk about what we use. We went with the Lynx distribution system. It's really just a fancy bus bar. But there's a few things I like about it. One, it's really quality, super heavy metal. It can handle, I don't know the amp number offhand, I'll look it up, but it can handle more power than you're putting through this thing. But it also has two main positive negatives where you can connect like your battery to, that you don't have to take one of your spots on the bus bar, and it's all covered. So you take the lid off and you can connect each component, very organized. It has spots for fuse holders, and then you can put the cover back on. It's just really neat and clean. We ran the ground wire from the solar charge controller to the Lynx distribution as well, which eventually will run the ground to the main chassis. From the bus bars, or in our case, our Lynx distribution, you will see we have two wires running to our inverter charger. This is going to take your 24 volts and invert it up to 110 volts so you can run your AC appliances. On the front of the inverter charger, there is an output that you can run your 3 wires to your distribution panel, where you're going to connect it to your main circuit breaker. We'll turn off and on all of the power in there that feeds to each individual circuit. Back to our Lynx distribution, we have 2 more wires that are just our DC wires. So normally, if you're in a 12 volt system, you would run these right to distribution. But being that our battery bank is putting out 24 volts, we need to convert this back down to 12 volts so all of our lights and stuff don't get burnt out. You definitely want to do that, or you're going to burn out all your 12 volt appliances and maybe start a fire. I don't know. I haven't done it. I wouldn't recommend it. There is one more wire that comes off of the Lynx distribution, and it's actually a ground coming from the inverter charger. And then there is a ground wire that comes off of the whole distribution to the chassis. So the inverter charger and the solar charge controller are meeting back at the Lynx distribution with grounds, and then the ground runs from the negative on that side to the chassis. I want to talk a little bit more about the inverter charger. There's one more set of wires I didn't mention, and that's the wires coming into the front of the inverter charger for shore power. This is really cool. We actually don't have this on our bus. I think we're going to probably install this same system. It wasn't that we didn't want to do it. It just wasn't super important. We have such a big solar array that we're like, I'll deal with it later. It is nice to have, even if you have a large system, the option of plugging in. One, for like running things like air conditioners. 2, I don't know, maybe you're in like a place where there's just no sun for a week or 2 weeks. At worst case, you can go pay for a campground to plug in, or a friend's house, and your batteries will be fine. You just plug them in, charge them up. So it's really cool because it's going to be our inverter, but also now you can plug in the shore power. And it's so nice, it just has an automatic switch relay. So as soon as it reads that feed of shore power coming in, it's going to switch off the inverter, bypass it, and send your shore power back into your system to both power all your stuff and charge your batteries at the same time. You can tell it if you want it to prioritize shore power or your batteries. And it's really cool. I mean, otherwise you'd have to get these components separate. So you have to get an inverter, you'd have to get a charger, and then you either have to do a manual switch that you'd have to do every time, or you have to get another automatic switch box. So it starts getting more messy. So while this inverter charger, I was like, whoa, this is pretty big when we got it. It's probably still a lot smaller than having an inverter, a charger, and a switch relay. And it's definitely a lot neater with all the wires. I think it's a really good way to accomplish those two things if you're trying to have both an inverter and shore power and you don't want to deal with manually switching things.
We chose lithium batteries in this build, and we fully recommend lithium to anyone doing a build right now. Lithium is definitely the way to go, and even more so now because there's a lot of competition within the lithium battery industry. So prices are coming down from those big brand name batteries. But one thing that we're seeing is that these new companies that are popping up, you could talk about maybe the quality versus the big name brands, but they're not including a low temp disconnect.
For whatever reason, these companies just haven't been putting these low temp disconnects in the batteries yet. I'm sure they'll catch on here. It's not like it costs them much, but until then, you have to be aware of this. And the reason is, if you charge your lithium iron phosphate batteries below freezing, they will be damaged permanently and you can't use them anymore. Particularly selling this bus, we realized somebody might be getting this that is overwhelmed by all these things. So maybe they're aware that this is an issue. There's so much going on, and maybe they run out of heat and they're not remembering, oh, I need to disconnect my batteries. So we wanted to have the safety in place. So we decided to go with battery that did not have the low temp disconnect, but accomplish this with our charge controller. There's a few out there that can do this, not a lot in my research that I found, but the one we found, it has a temperature sensor that you can run to where your batteries are, and you can program it. So the actual thing that would be feeding the batteries, which is your charge controller, will shut off or disconnect the feed once they get to a specified temperature, say 35 degrees. So they're accomplishing the same thing that is built into some of these other batteries. Put simply, we got it done, just had to do it a little differently, and it really isn't that complicated.
We have another solar video out on YouTube, and that is a breakdown of the system that Drew built into our bus. The bus with the green cabinets, the one that we live in. If you've watched that video, you will have noticed that that system is very different than the system that we built into this new bus. The bus with the blue cabinets, that's the one that we will be selling very soon. The system that Drew built into this new bus is different because we are selling it. We wanted to put very concrete safety measures in place so that if whoever gets this bus doesn't know a lot about solar and electrical and all of these components and something goes wrong, the system can trip and it can stop something catastrophic like a fire or any kind of other problems. This system is very different. It's a lot more self-sufficient. We did not build from cells like we did in our bus. These are prefab batteries that came packaged and ready to go.
Even with ours, it's like a little more open source and all that. So we're taking all the components and sort of bringing them together. So we wanted to put the new owner of this bus in a position where they could at least have somebody to reach out to if there was an issue. If something with the battery went wrong, there's a guarantee and there's tech support, so they can call that company.
This is a pretty good summary of the system that Drew's been designing and working on all week. I'm going to do my best to link all of these different products and things that he used in the description below. I will have them all under one link so you can click that and look through all the things that we used. So far, everything's been working really well, and I think we've been really pleased with how everything's performed.
Yeah, I like all the products we use so far, and some of it you have to run it. Time will tell if there's any little hiccups, but it seems to be running really good. So we are encouraged by it, and we think it's going to be great. We got all the components we could get on this board and did all the wiring we could do outside of the bus before we get into that tight compartment. To bring this in, and then we can get the wire lengths figured out from the battery and to the inverter and to the distribution block.
Is it time to finally turn the power on?
We are gonna see if the inverter is working. It's all hooked up, so.
All right.
See if any sparks fly.
I get to turn the big red button right here from off to on. Ooh, everything came on. So far, so good.
Switch the inverter on. Yep, lighting right up. Outlet lights up.
Ah, it's charging your phone.
It's charging the phone. So this is live. Now we just gotta get the real output connected to the distribution box.
Congrats.
Pretty good.
High five.
So just 8,000 more connections and we'll be there.
As we have talked about before, electrical is not really my thing. So this week has been all about me just handing tools to Drew, which is a welcomed break from building all of these things and painting them.
Yeah, you need a wrench.
Oh.
Need a wrench.
Here.
I'm just kidding.
You scared me!
I don't know what's worse, the whole thing or the sound I made.
I almost had a heart attack.
It's not even funny, it's so bad. Okay, I've wired in the light switches to all the overheads, and we're going to find out if I have my 24 to 12 volt step down correct. I'm going to switch this on and hopefully we don't get any sparks. Yes!
Woo!
We got lights!
Oh, it looks so good!
Woo! Yep, panels are working. Sweet. Dimmer. Yep.
They look so good.
Finally.
Good job.
There you go. We got airflow.
The first switch that we turned on was for the overhead lights, and being able to just hit that switch and having the lights come on, totally hooked up into the system, it's feeding itself and it's powering itself, that's an exciting moment.
Yeah. Lights, lights, lights.
The last part of this week was running some light strips that we discovered when we did our bus build. These light strips are really great. They're LED, they're adhesive, they're really cheap to buy. So we always put a bunch of them in our buses because you know what's frustrating? Digging through dark cabinets and
Yes.
storage spaces. I think these lights are maybe $15 a piece. You can order them off Amazon and stick them into all the corners and edges of your storage spaces. It really helps with finding things that you need. Just having light in those spaces makes a world of difference.
Once you actually live it and live in the space, there's always something you didn't think of. Under the bed. Didn't put a light there. It's so horrible trying to get stuff. So this bus has under the bed lights. It's so cool. It looks really good.
We put these strip lights underneath the bed because that is a large storage space. We put them underneath all of the overhead cabinets. They are all each individually on their own switches. So you don't push one switch and all the under cabinet lights come on. They have their own. So if you're sitting in bed and you want to read, you can flip that one on. If you're in the kitchen, you can turn that one on without having them all come on at once. When the closet at the end of the bed and the storage space above the cab are finished, those will be getting strip lights as well, but they're not completely done, so we're not ready for that yet. A little surprise that I've been planning since I built these overhead cabinets is putting strip lights at the top of the overhead cabinets, shining up at the ceiling.
Yeah.
I think this is so cool. It's kind of an ambient lighting. It's really nice mood lighting. It shines up at the ceiling, so it showcases the beautiful cedar on the ceiling. I left this gap on the overhead cabinets. Our bus does not have a gap up there, so we have no place to install lights like this, but I've been planning this for weeks and weeks since I built those cabinets, and finally this week it came to life. We pushed all the little strip lights up in there, turned it on, and it was so nice and so beautiful.
Starting to get jealous of all the extra lights in this bus.
I'll let you go, just need some time. At your own pace, you need to find your way. I know now you'll never change your mind for something that matters to me. You do not know what I have in mind. I packed our bags, we'll be on our way.
Once we had our solar wires connected to distribution, battery bank, and all that, it was time to test out the system, roll that baby out into the sun, and see what kind of power we're generating. Very exciting moment.
Pushing this bus out into the sun for the first time with everything fully hooked up is a huge moment.
Yeah.
It's really exciting to see all of these things functioning exactly how you designed them. The bus is taking in sun and converting it to energy. Now you have all of the things that you need to run your appliances and be completely off grid in this bus.
Okay guys, that's it for week 14. I know that was a lot of information. Tried to glaze over it as much as I could, but it's just too much. Hopefully you got a decent understanding. Point is, we now have a fully functional mobile solar generated power station to run everything you need.
We know that this is a ton of information, so if you have a lot of questions for us about designing your own system, we do ask that you go on our website and book a consultation with us. This information is so dense. There is a lot to convey. So the best way for us to do that with you is through a one-on-one session. You can go to ourwaytorome.com and find the consultation page. We will link it below. We want to give a huge shout out to our brand new Patreons this week. Thank you so much for joining that platform with us. We're getting really close to Patreon exclusives, so we're excited about that. Week 14, we are going through it. Thank you so much for being here. Do all those things you do on the internet, and we'll see you next time.